Hey guys, my name is Andres and I'm going to explain you an exam of Calculus 1 that was taken in my university in 2015. So let's go for it. Okay, so the first problem says determine the truth values set for x that belongs to the real numbers. So in this case, they want to find the x that satisfies the inequality, which is the x that are going to be greater than 0. So first of all, we write the equation, as you can see here, and then we try to find or analyze if we can factorize this equation. So in this case, we can, right? And we're gonna do it this way: x minus x minus. So this is gonna be 3 and 1, right? Multiply 3 and 1, we're gonna have 3, and if we add 3 and 1, we're gonna have minus 4. Okay, so this is gonna be divided by x minus 1, minus 1 over x, greater than 0. As we can see here, we can simplify this expression, and we're gonna have x minus 3 minus 1 over x. So here we have a method that helps us each time, right? So I'm gonna multiply by x and x. I'm not altering the equation, right? And we're gonna add the terms if we want, right? So this is gonna be x squared minus 3x minus 1 divided by x, right? Greater than 0. So if I multiply x by 0, I'm gonna have x squared minus 3x minus 1 greater than 0. So in this case, we can factorize the equation. So I have to apply the quadratic equation. That's gonna be this way: minus b b squared minus 4ac divided by 2a. If you don't remember, this is gonna be the coefficient. It's gonna be a, the coefficient is gonna be b, and the coefficient is gonna be c here. Okay, so let's do it. This is gonna be minus 3. It's gonna be minus 3, right? And here we're gonna have minus 3 squared minus 4 multiplied by a, which is 1, and c is minus 1 divided by 2. Okay, so in this case it's gonna be, let me see, 3, and here we're gonna have 9 multiplied plus 4, it's gonna be 13 divided by 2. Okay, so x1, it's going to be 3 plus square root of 13 divided by 2, and x2, it's going to be 3 minus 13 divided by 2. Okay, so we have to find these values in the calculator, right? So let me see. Plus 3 divided by 2. Okay, perfect. So this is gonna be, just use 3.3. Okay, and the second one is going to be let me see, minus 0.3. Perfect, guys. So now that we have x1 and x2, we need to make a draw in order to understand where the x1 and x2 are going to be located. Okay, so we do it this way. Perfect. Here I'm gonna have, I'm gonna use here 0, right? And here I'm gonna use, let me see, x2, because x2 is negative. And here I'm gonna use x1, okay? And here we need to find the range where the solution satisfies the inequality. So we're gonna have to take a values that will satisfy this equation. So let's do it, okay? Here we have minus 0.3 here, okay? So we're gonna take here minus 2. Here I'm gonna use, because this is minus 0.3, I'm gonna use here minus 0.1, right? Here I'm gonna use 2, and here I'm gonna use, I don't know, 5. So the expression is this one, and I'm gonna put it here just so you know. Okay, perfect. So we're gonna have here, okay, so if it's minus 2, we need to find the equation, right? So we do it on the calculator. It's gonna be minus 2 squared minus 4 minus 2 plus 3 divided by minus 2 minus 1. This is minus 5 minus, positive, because this is 1/2, right? Minus 2, and the minus is gonna be plus. Okay, so gonna be a positive. So now we have minus 9/2 greater than 0. No, this is false, because this is a negative one. This is a negative value, so this is false. And here we go, and we cross this section. Why? Because we know that the solution is not gonna be here in this interval. So we have to analyze the second one. So for the second one, I'm gonna use minus 0.1. Let me do it better here, okay? Minus 0.1, okay. Minus 4 plus 3 divided by this is gonna be minus 3.1 minus 1 divided by minus 0.1, okay? This have to be greater than 0. So here we're gonna have 6.9 is greater than 0. Yes, sir. This is true. So here we mark it and we say, yeah, it's good. Now we have to analyze the following intervals. So let me do something like here, right? And I'm gonna say, so for 2, right? 2. Okay, let's do it. So here we have minus 1.5 is greater than 0. No, sir. This is false. And for the next one, this is 5, right? So for 5, let's do it. This is, sorry guys, sorry. Okay, So this is 1.8. This is greater than 0. Yes, sir. This is true. So, okay, let me do it. This is, okay. So this is no, and this is a yes. So now that we know the interval of this inequality, we have to do it, right? And let me do it. I'm gonna do it here, okay, guys? So please don't get confused. So here I'm gonna say so my APDX, which basically is the interval where is located the solution, is going to be from x2, right? From x2, this is x2. Don't get confused. From x2 to 0, and then from x2 to infinite. So here we have x2. But what is x2? x2 is going to be minus 0.3 to 0. It's a union, right? Just so we say that you're gonna add these intervals. And you from x1, what is x1? 3.3 to infinite positive. Remember, this one is x2. This one is x1. So what would happen? I mean, maybe you can ask, okay, Andres, but what happened if I include the x1 and x2, right? x1 and x2, yes. What would happen here is that here in the equation, they're telling me the greater than 0. If we plug x1 and x2 in the equation, which equation? In this equation, you're gonna have that the result is gonna be 0, and it's not satisfying the inequality. So in case, just in case, we have here equal to 0, then this one is gonna be a closed interval. This one is gonna be a closed interval. Sorry, exactly, perfect. Yeah, it's gonna be a closed interval. But because we don't have that situation, then you can't say that. Okay? So that would be the solution, guys. So I hope you like it, and I'm gonna make more videos for you. Thank you. Take care.